Okay. We are doing uninterrupted flow facilities and we are focusing on different segments of freeways. Okay, so we know the basic freeway segment which is outside the influence of the ramp. The one which is in the influence of the ramp, it can be a merge segment, a diverge segment, and both of them have the same procedure for analysis which we already covered. Now what we are doing is the weaving segment. So weaving segment is basically a merge and diverge segments which are very close to each other and they are connected with an extra lane which we call as the auxiliary lane. Okay, so this is what we call as a weaving segment. Okay, in a weaving segment, the most important item is the number of lane changes because people are coming in and going out at the same time or in a short distance. So there are lots of lane changes. So this is the most prominent aspect of this thing. Some examples. Okay, so we are going through this methodology, find out data about the volumes, find out data about the highway characteristics, number of lanes and so on. Find out if your segment can be a weaving segment. So there is a standard length. If your distance, actual distance is more than that standard length, it's not weaving. Okay, the ramps will not affect each other. If it is a weaving segment, then you move forward and the first thing you do is check for the capacity. If the demand is over capacity, the level of service is F, otherwise you find out what is the level of service. And as I mentioned, the most important part of finding out the level of service is the lane changing. How many lane changes are required? And then after that, you can find out speed, density, and level of service. Okay. The things which we need are these. I went through them earlier as well. So these are basically related to the lanes and the distances, the segment capacity, the terrain type, okay, interchange density, volumes. And what is this weaving lane? What is a weaving lane? Anybody remembers? What is a weaving lane? Weaving lane.
The one which is nearest, which is we can interval.
Only comes to the lane can go to the out of the freeway and one of ramp to
in one change. Yes.
in one change.
In one change. Okay. So okay, fine. Okay. So if you look here, from ramp to freeway, I can take one lane. So if I'm coming from the ramp, I'm here, right? So ramp to freeway, I will make one lane change, I will be here. So this is my weaving lane. Okay. If I'm going from freeway to ramp, from this way, lane, I can make one change and go to the ramp, right? Okay, so this is also my weaving lane. This one, two weaving lanes. Okay, two. This one, and see this is different now, slightly different. Okay, so if you are coming from the ramp, okay, you can you make one lane change and go to the freeway from this lane? Can I make one lane change and go to the freeway? No. If you make one lane change, you are still on the ramp. Okay, so this is not weaving lane.
Don't hide the road door. You don't see the two lanes.
You don't see the two lanes? Now you can see it?
Yeah.
Okay. This one, yes. Okay. So you can go from the freeway to the ramp with one change. You are already on the freeway. Okay. Now, even if you continue in the same lane, you will be on the ramp, right? This still qualifies for weaving lane. If you can go from the freeway to the ramp without any change, still we call it a weaving lane. Okay, maximum one lane change. But if you can do it without any lane change, still it's a weaving lane, which is happening here. Freeway to ramp, no change required, right? Just continue. Okay, freeway to ramp, no. You have to make how many changes? One. From here to here, then you are on the ramp. Okay, again, how many weaving lanes? This one and this one, but both are for what? For freeway to ramp. There is no weaving lane for ramp to freeway. There is no way you can go from ramp to freeway with one change. Okay, so ramp to freeway nothing, freeway to ramp 2. So total is 2. Clear? Okay. Now on bridges, sometimes we have this type of arrangement. Entry from one side and exit from the other. Okay, so the entry ramp is on the left hand side and the exit ramp is on the right hand side. Okay, so in that case, if you have to go from, so we call it two-sided weaving. This is called as, both these cases are two-sided weavings. Okay, so you are coming in from one side, going out from the other. Okay, so in two-sided weaving, we only have weaving for ramp to ramp. Freeway to ramp is not weaving. You come in from the ramp, the lane which you will enter is the freeway. No weaving is required, no lane change required, right? You will enter the ramp, you will come from the ramp, and when you are out of the ramp, you are on the freeway. No lane change, right? Okay, same thing. If I am in this lane, I am going to the ramp, this is the lane. No lane change required, right? Okay, so ramp to freeway, freeway to ramp, no lane change is required. Only lane changes required are from ramp to ramp. Okay, clear? So in that case, we don't we don't consider the number of weaving lanes then. Okay, so number of weaving lanes are considered when we have one-sided weaving. This is one-sided. Okay, both ramps on the same side. In that case, we don't consider it. Okay, why are we considering it? To find out number of lane changes required. Minimum is what is required. Minimum is meaning required. Okay, you have to make it. Okay, so how many lane changes required? Number of people who are going from ramp to freeway. Flow from ramp to freeway. Multiply by lane changes required to go from ramp to freeway. Required, keep it in mind, required. How many lane changes required to go from ramp to freeway? 1, right? You cannot do it without this. Okay, you cannot go from ramp to freeway without this. So 1, right? So this one will be 1, and then you multiply with the flow. It will give you number of lane changes. Same thing here. To go from freeway to ramp, I need how many? 1, right? I have to make this one. Without this thing, I cannot go to the ramp. Okay, so 1 and multiply with the flow, which will going in this direction. Okay, clear? What about here? What did I tell you about this one?
There is no change from the ramp to the.
Yeah. Okay. So there's ramp to freeway 0. No. Oh, it was no. Ramp to freeway, you have to make 2 changes. It's not a weaving lane. Weaving is something else. I'm talking about how many lane changes are required. How many lane changes? If you are on the ramp, you want to go on the freeway. How many lane changes you require?
2.
Okay. So ramp to freeway 2 required. If you are on the freeway, you want to go to the ramp. How many lane changes required?
1.
0. You can go on the ramp in the same lane. Okay. So freeway to ramp 0. Okay. So this one will be multiplied by 2 because you need 2 lane changes, and this one will be multiplied by 0 because you don't need any lane changes. Clear? Okay. We are talking about lane changes right now, not number of weaving lanes. Number of weaving is clear, right? Okay. There is something else. You will consider it somewhere else. Okay. What about this one? The lane changes are required by who? Which people? Going from where to where? Ramp to ramp. Okay. So ramp to ramp, how many lanes? You count it. Multiply by the flow from ramp to ramp. Got it?
But isn't it will be 0 because ramp to freeway will be 0.
Which one?
No one there.
There we are not considering ramp to freeway.
Okay.
And freeway to ramp not considered, because freeway to ramp, ramp to freeway, no lane change is required.
So
You can just be on the freeway and just take the exit. That's it. Okay. Who will be required to make the lane changes? People who are coming from this ramp and they want to exit, so they will be required to make the lane changes. How many lane changes? If there are 3, then 3 lane changes. If there are 4, then 4 lane changes. 2, then 2 lane changes. So all lanes are required. But for who? Only for these people, ramp to ramp. Okay? So you take the flow of ramp to ramp. You take the flow of ramp to ramp, multiply by the number of lane changes to go from ramp to ramp only. Okay? So this one is for one-sided weaving. This one is for two-sided weaving. Okay? In this case, this one is 1, this one is 1. For this case, okay, this one is 2 and this one is 0. Okay, so you have to look at the, so this is why we said we need to look at the configuration. Configuration means where are the ramps, how many lanes are there, how many auxiliary lanes are there, and so on and so forth. Clear? Okay?
In WL, the difference between LC and WL.
This is different. WL is weaving lanes. From how many lanes you can go to the ramp to freeway, freeway to ramp with 0 or 1 lane change. The same thing which we discussed last time. You told me, right? Okay. So there are no weaving lanes here. In this case, no weaving lanes. Okay. Or you can consider 1 and 1. You are on the freeway, you want to go to the ramp. 1. You are on the ramp, you want to go to the freeway. Maybe 1. Okay. So it depends. But these are two different things. Lane change is required and number of weaving lanes. These are two different things. Okay. Clear? Any other question? Then I said, whatever distance you have between the ramps, you should check it with a standard length. Okay, and the standard length is called as Lmax, meaning weaving length. Okay, to calculate weaving length, I need VR and number of weaving lanes. VR and number of weaving lanes. So this is where we are using the number of weaving lanes. Okay, and what is VR? Weaving volume upon total volume. VR is volume ratio. Volume ratio meaning weaving volume upon total volume. Okay. Now, what is the weaving volume? Weaving volume means what? People who are doing what? Changing lanes. Required. They are required to change the lanes. Okay. So, in this case, one-sided weaving, right? People who are going from freeway to ramp, they have to make the change. People who are going from ramp to freeway, they have to make the change. Here, people who are going from ramp to freeway, they have to make the change. Okay? And people who are going from freeway to ramp,
0.
okay? So this will not be weaving. This will not be considered weaving. Freeway to ramp will not be considered weaving in this case. Okay? What about these two cases? What is weaving?
Ramp to ramp.
Ramp to ramp only. Ramp to ramp only. Everybody else is non-weaving. Clear? Clear? So weaving is who has to make a lane change. Who has to make a lane change. Okay? Divide by total. Okay? Divide by total. So this is VR. Total is everybody. Weaving, non-weaving, everybody. Clear? Okay? And number of weaving lanes I already explained. Okay? If your weaving distance, the auxiliary lane distance between one ramp and the other ramp is more than Lmax, more than this standard value, that means it's not weaving. The segment is not weaving. One ramp does not affect the other. This is what it means. One ramp is not affecting the other. Okay, so you don't have to consider them as a weaving segment. Weaving segment means what? Both ramps are very close to each other and one is affecting the other. Okay, but this will only happen if the distance between the ramps is less than Lmax. If it is more, it's not weaving. And if it is not weaving, and then it's what type of segment? Huh? What type of segment is this? Merge and diverge. Okay, so this one will become merge, this one will become diverge. Same thing there. Okay, weaving is not available. Clear? Okay, so you can use this equation to calculate Lmax, or you can use this graph. Okay, to find out the value of Lmax. So this line is when you have 3 weaving lanes. This line is when you have 2 weaving lanes. Okay, and you put the VR value here, and you will find out the maximum length. Okay, so this will give you L max. This graph can give you L max. Okay, so you can use the equation or the graph. Okay. Okay, so let's say you found that your distance is less than L max, so it's a weaving segment. Next step, check if the demand is more than capacity. Demand is more than capacity, level of service is what? F. Okay, otherwise you will continue, find out the actual level of service. Okay, CIWL, capacity of a weaving segment in ideal conditions per lane. Capacity of weaving segment in ideal conditions per lane. This equation will give you per lane capacity for a weaving segment in ideal conditions. What are the ideal conditions? Ideal conditions are that you have only passenger cars. Okay, so this will give you capacity in passenger cars per hour per lane. Okay, then we have what is the check? The check is this. Okay, this is the check. What is saying? If you have two weaving lanes, then your total ideal capacity should not be more than this value. Okay, so this is the maximum for the total ideal capacity, the maximum for total ideal capacity with two weaving lanes. If you have three weaving lanes, total ideal capacity equals to this. Okay, so this or this. Okay, clear? What are we saying? Calculate the per lane capacity from here. From per lane you will convert it to total. How? Multiply by what? Number of lanes. Okay, so you will get total capacity. That total capacity should not be more than this ratio or this ratio.
And this is the
If it is, then
take this.
you take this one. Okay, so this equation gives you, let's say 1000. Let's say this equation gives you 1000. You multiply by number of lanes, you get 3000. Okay, so this ratio should be more than 3000. These ratios should be more than 3000. If they are less than 3000, if you cancel 3000, you will take this one. Okay, so your capacity will be either from here or it will be from these ratios. Okay, and whatever value you have for the capacity, in the end that value should be more than the total demand flow you have. Okay, this value should be more than the total demand flow you have. If it is less, that means what?
Loss is F.
Level of service is F. Okay, clear? Clear? Okay, what are we using in this equation? What is VR? Virtual reality, right? We are all in it right now. Huh? It's all a dream. We'll wake up soon. What is VR? Ratio of what? Huh? Weaving upon total. Okay, weaving upon total. Let us call it flow. Okay, flow. It will not change. But anyways, LS. What is LS?
Auxiliary lane.
Yeah, length of the auxiliary lane, meaning the distance between the two ramps. Okay, and what is NWL? Number of weaving lanes. Okay, now CIFL. Okay, capacity of basic freeway per lane under ideal conditions. Capacity of basic freeway per lane under ideal conditions. Okay, now from where do we have it? We have already used it when we were doing the basic freeway segment. there are equations for this, or equation 1. This one. Okay, so what do I need to put here? Yes. Okay, so this will give you CIFL, capacity of freeway under ideal condition. This is already per lane, so you don't have to worry about per lane or total. Clear? Okay, so the capacity check is that you calculate the capacity per lane for the weaving segment. Then you convert it into total capacity by multiplying with number of lanes and check. The total should not be more than these ratios. Okay? If it is more, then you will take the capacity as these ratios. The final value will be one of these values. Okay? And then you compare it with the demand flow rate you have. The demand flow rate you have. The demand flow rate is more, level of service is F. Demand flow rate is less, you will continue. Okay? Okay? Clear? Now keep one thing in mind. Total flow, here total means total. Ram to ram, freeway to ram, ram to freeway, whatever. Everybody. And the number of lanes is also total. So it will include what? Lanes for the freeway plus the auxiliary lane. Okay? Clear? So number of ramps, number of lanes and flow, everything is total. Everything is total. Okay. Yeah, for capacity you may have to apply some adjustment factors. We have talked about adjustment factor for work zone, weather, and so on and so forth. Okay. If the level of service is not F, then we can move on to the next step. The next step is to find out the rate of lane changes. Rate of lane changes, meaning lane changes per mile. Rate of lane changes meaning lane changes per mile. Okay. There are 3 types of lane changes happening in these segments. 3 types of lane changes happening in these segments. One of them is required and the other 2 are not required. Okay, just like life. Okay. Out of 3 things you do, 1 thing is required only. The other 2 are just wasting your time. Okay. You just take 1 class every day and just go home. Okay. And that is my class. Okay. So required lane changes are by people who are going from ram to freeway, freeway to ram, and they have to make the lane change. Without lane change, they cannot go to their destination. Okay, the one which I showed you in this figure. So freeway to ram, required. Ram to freeway, required. Freeway to ram, not required. Okay. Ram to freeway, required. Ram to freeway, not required. Freeway to ram, not required. Ram to ram, required. Clear?
Total is total.
Total is total. Okay. These are the required lane changes. These are the required lane changes. What are the unrequired lane changes? Somebody who was in the going from ram to freeway and freeway to ram, but he was in the wrong lane. So he will make extra lane changes, required or not required, but he will make extra.
You with 1.
Why is he looking at you? You come here. Come.
I can't see it.
Come. Don't see. Come.
No, I will not believe now, so.
Huh?
I will not believe.
Awesome.
Okay. Okay, so lane changes which are for people who are doing the weaving, but they are required to make extra lane changes because of their misposition. Okay. And then optional by non-weaving, who will remain on the freeway or who are just going from ram to ram. Okay, so they are not required to make any lane changes. Okay, but they are just trying to avoid other people. Okay, which is a good thing. Avoid others.
Peaceful mind.
Yes, go home.
Good.
Yeah. Okay. Clear? Okay. required people who have to make the lane change, otherwise they cannot continue on their trip. People who have to make the lane changes, who are weaving, but they are in the wrong lane, so they will make extra lane changes. People who are just trying to avoid the other people. Okay, clear? Okay, 3 types of lane changes. We already calculated the first one, which is here. These are required. These are required lane changes. The first category is here. Okay. Then the 2 optional. Okay. So what were the 2 optional? What were the 2 optional lane changes? Tell me.
Extra lane, wrong lane.
They are in the wrong lane. Okay. So this is this one. Okay. This one. So this is the required one, which you already calculated, plus this thing. Okay. What is LS? The lane, the length of the auxiliary lane, ram to ram, distance ram to ram. Okay. And total number of lanes. N is total number of lanes. Okay. And ID is interchange density. Okay. So number of interchanges, we did it earlier as well. We called it ram density earlier. Okay. That was 3 miles forward, 3 miles back. Count how many interchanges you have. There we were counting ramps, not ramps. Number of interchanges. So you go 3 miles forward, 3 miles backward, count number of interchanges, divide by how much? 6. Okay, so ID is interchange density. Clear? Okay. Okay. So these are things. So this will give you optional lane changes by the weaving people, including both. Okay, so this is the required amount and this is the optional amount. So total of the weaving. This is total number of lane changes by the weaving people, optional or required. Okay. For the non-weaving people, we have 3 possibilities. Non-weaving. So people are just trying to avoid the ramps and the disturbance. Okay. Which of these equations I will use? It will depend upon the intensity of non-weaving. INW is intensity of non-weaving. Okay. So LS ID flow of the non-weaving people divided by 10,000. Okay. So you can calculate this value and then you put it here. So you will know which equation to use. Okay. If this value is less than 1300, first equation. More than 1950, second equation. Between 1300 and 1950, third equation. Okay? So this depends upon this one. Okay. Now they have given us an extra condition here to keep on doing this. Okay. If you are going to use the first equation, let's say. Okay. If you use the first equation, so your INW is less than 1300. You will use this equation to calculate how many lane changes for the non-weaving people. Okay. This number should be more than the value you will get from here. Otherwise you cannot use this one. You have to use this one. Okay. So this one, the second equation, can be used in 2 cases. The second equation can be used in 2 cases. The first case is your INW is more than 1950. Then you will use this one. Second case is your INW is less than 1300. But the value you are getting is less than this one. Okay. So either the INW is more than this value, or the INW is here, but this value is less than this one. Okay. Clear?
So if my case was the first one.
In the first one, you will calculate both of them and compare. Okay. If you meet this condition, then you have to use the second one. Okay. If your case was the first one, then you have to calculate both of them and compare. And you will use whichever is higher. Whichever is higher. Clear? Okay. So This was lane changes by weaving people, required, non-required. Lane changes by non-weaving people, one of them, and then you add them, you will get total number of lane changes. Okay, total number of lane changes. Okay. The final step, we calculate the speed of the weaving people. For that we need W. W is this one. We can calculate the speed of the non-weaving traffic, speed of weaving traffic, non-weaving traffic. We can calculate total speed, average speed of the whole segment, okay, and density of the segment. Average speed, density. The speed of weaving, speed of non-weaving. Average speed, density. If you know the density, level of service is from here. Okay, now look at these equations. Tell me if there is anything new. Is there anything new in these equations? W coming from the equation, no problem. Weaving intensity factor. Anything else? Huh? What is V? Tell me. Small v. What is V? Which flow? Which one? Total. Okay. So this plus this will be total V. Okay. And N, as I said, total number of lanes, including the extra one with the lane and everything, with the ramp and everything. Okay. Rest of the factors are all the same. Okay. We have a standard ramp weave segment. What is a standard ramp weave segment? Not this one. The first one, this one. This is called a standard ramp weave segment. Okay, so you have one auxiliary lane, ramp to freeway, you will make one change, freeway to ramp, you will make one change, and the number of weaving lanes are these two. Okay, from these two lanes, I can go from freeway to ramp or ramp to freeway with one change. So these are my weaving lanes. Okay, this is called a standard ramp weave segment. Okay, free flow speed 65. Short length meaning the length of the auxiliary lane. Okay, the distance between the two ramps. This is given. The flow on the main line 4650, entering volume 875, exiting volume 730. Okay, so the freeway already has a flow of 4650. From them, or in them, 875 will enter from the ramp, and from them 730 will exit from the ramp. Okay, and ramp to ramp flow is 175. So they will come from the ramp and this. They are taking a U-turn, right? They are taking a U-turn. All traffic has 10% trucks, level terrain, interchange density is given 0.9 interchange per mile. Find out the capacity and level of service. Okay. Now, the first thing which we do is we convert these values to flow rates in passenger cars. Okay, we need to convert all these values to flow rates in passenger cars. Okay, so how do we convert volume to flow rate?
Divide by PHF and FG.
Yeah. Okay, so volume divided by peak hour factor and what else? FHP. Okay. Peak hour factor not given, right? Okay, so obviously we cannot calculate it. We will assume something. Let's assume 0.95. Okay, we are assuming it should be given. Okay. FHV. Okay, percentage of trucks 10%, 0.1. ET for level terrain is 2. There's a table which is given in the same chapter. You can have a look at it. but ET for level terrain is 2. Okay, so PT percentage 10%, ET is 2. Okay, how much? Factor for heavy vehicles. 0.91. Okay, so now we calculate the small v's, meaning the v for freeway to ramp, ramp to freeway, and so on and so forth. Okay, so for example, 4650 divided by 0.95 and 0.9, how much is that? 91. Yeah, 537. Okay, 5378 passenger cars per hour.
9.
Okay. Okay. So entering volume means ramp to freeway. Entering is ramp to freeway. So how much is that? So you take the entering volume and divide by the same factors. How much is that? Okay, then freeway to ramp, meaning what? Freeway to ramp is which one? Exiting. How much? So do the conversion for 730 then. Okay. And how much is this? Ram to ram 175 volume, and that is sorry, no, they're saying volume and then flow. Okay. Yeah, how much? 175 divided by 202. Okay. I need one more thing, which is freeway to freeway. What is freeway to freeway? Which volume is freeway to freeway? You don't have to divide by any factor. You already have all the values.
Total minus the ramp.
Huh?
Total minus the volume of go
Yeah,
to ramp.
this one minus the freeway to ramp. This one was already on the main line, right? This is already on the freeway. From there, these people are exiting. So the remaining will go freeway to freeway, right? Okay, so this minus this, how much? 4535. Okay, this is they gave me, but I will call it main. Okay, so you don't get confused with the rest of the things. Okay, your total is total of these four. When I say total volume, is total of these four. Okay, freeway to ramp, ramp to freeway, ramp to ramp. These four. Okay, how many of them are weaving? How many of them are weaving? Which of them are weaving?
From freeway to ramp.
Okay, the rest are non-weaving. Okay, first thing we need to check is it a weaving segment or not? Is it a weaving segment or not? So we will calculate L max. For L max, I need the VR ratio, the volume ratio. Volume ratio was weaving upon total. So weaving is 1012 plus 844 divided by the total. How much is that? Three. Okay. L max. This is L max. Okay. So VR is 0.3, NWL is 2. Give me this value. If I want to use a graph, obviously I cannot use it accurately. So I have two weaving lanes, standard segment, standard weave, two weaving segment. This value is 0.3, so from here to here. Okay, so it will be something 5,000 something. Okay, 5,000 feet something. Okay, how much is my LS? The distance they gave me. How much is the distance? 1,850. Okay, so even from the graph, even if I don't know the exact value, okay, I know my LS is less than L max. Okay, so I can just write it. So this is the weaving segment. This is a weaving segment. Okay, so I can use the equation of the weaving segment now. Okay. This is the capacity of basic freeway segment per lane. How much is that? My free flow speed is 65. So the capacity is how much? 2350 passenger cars per hour per lane. Okay, then how much is this? This is 0.31850 Okay, VR is 0.3, LS is 1850, NWL is 2, and this one 2350. Just calculate it. So how much is my CIWL? Two 2064. Okay, this is passenger cars per hour. Okay, I have 3 lanes plus 1 auxiliary lane. Okay, 3 lanes plus 1 auxiliary lane. So the total capacity will be what? CIW. You multiply this with 3. How much you will get? 6492. Okay, and then we have a check that this value should be less than 2400 divided by VR, which is 0.3. Is it? 8,000 what? 8,000. Okay. Okay, so capacity of my segment is how much now? Okay, and if you want per lane, then this is the total capacity, this is the per lane capacity. Okay, we did the first part. Okay, clear? Okay, write these values, take a picture, whatever. I will need them next time. Okay, so we will then do the level of service calculations. Okay, any questions? Okay, you can leave if you want.